Hey, Dr. Clark here, coming back at you with another example problem. This time we're going to do a non-homogeneous linear system. Let's take a look. So we've got a 2x2 non-homogeneous linear system. The example says, convert the forced spring mass damper setup given by x double prime plus 8x prime plus 15x equals 30t to a linear system, and then solve the initial value problem where the mass is released from rest at a point 4 units to the left of equilibrium. So it sounds like they've given us a second order linear differential equation. They want us to convert it to a linear system and then solve an initial value problem. So what's happening here is, at least conceptually, you've got a spring mass damper setup, and there's even like maybe a little rocket engine that's kind of shooting a force, because it says we've got a forcing term, so it's maybe pushing the mass to the right. Although if that was equilibrium, it sounds like they started it at position -4 units to the left of equilibrium from rest, which to me sounds like there was some kind of initial condition like x of 0 is -4, but the velocity was 0 because they released it from rest. So it's almost like an initial value problem here. But they don't want us to solve it using second order methods. They want us to convert it to a linear system, which means they want us to say that x prime is equal to y, the velocity, and y prime, the velocity, is equal to the second derivative of position. But we can solve x double prime in this equation for -8x prime plus 15, or not plus 15, but minus 15x plus 30t. But that's really the same as -8y minus 15x plus 30t, because x prime is equal to y. And once you have that, you can write it as a matrix vector problem, which is position velocity derivative equals matrix. So we're going to have 0, 1 times xy, because x prime equals y, so we want 0 times x and 1 times y. And then we need, we need -15x and we need -8y. But there's a forcing term, and the forces are applied to acceleration, so we're going to have 30t on the y prime. The x prime, there's no forcing term on x. So that is converting it from a second order linear forced differential equation to a forced first order system of position velocity. Okay, but once we've done that, we know how to solve it. We just find the eigenvalues and eigenvectors. That will generate a homogeneous solution. And then we can find a particular solution for this non-linear part to complete the system, in other words. Okay. So let's try to do that here. First, we got the matrix 0, 1, -15, -8. So 0, 1, -15, -8. We need the eigenvalues of that matrix and the eigenvectors. So we take the determinant of 0 minus lambda, 1, -15, -8 minus lambda. And if we do that, we get negative lambda times -8 minus lambda, minus -15 times 1, and we set that equal to 0. And if we do that, we're going to get lambda squared plus 8 lambda plus 15 equals 0. And I think that's going to factor into lambda plus 3, lambda plus 5 equals 0. So there's our two lambdas. Lambda 1 is -3, and lambda 2 equals -5. So we've got two eigenvalues right there. And then there should be two eigenvectors that correspond to those eigenvalues. So let's find the first one. The matrix 0, 1, -15, -8. If you multiply that times a random vector, most likely it both rotates and stretches that vector. But for an eigenvector, it only stretches it. It's the same as multiplying it by a constant -3. It stretches it by 3 units. Okay? Now, we have to find which vector it is that's in the right direction for that stretch to occur, because most of the time it won't work. So we multiply that through 0x plus 1y. That has to equal -3x. And -15x minus 8y. That has to equal -3y. Now, this looks like two equations and two unknowns, but this first equation just says that y is equal to -3x. And actually, the second equation says the same thing. It says -15x is equal to 5y, which means that y is equal to -3x. So notice both equations are saying the same thing. They're saying that if you take the vector x equals 1, and therefore y would be -3, because if x equals 1, y has to be -3 times 1. So that's one eigenvector. Now, you could pick 2, -6, or 10, -30, or 100, -300. Whatever your x is, the y-coordinate is -3 times x. But the easiest thing for x is to be 1, and then the y has to be -3. So that's one of the eigenvectors. And the other one, well, we should be able to solve it similarly. We just take the same equation times xy, but this time it's going to equal -5 times xy, because that's the eigenvalue. And we can cut to the chase. The top equation says y equals -5x. The bottom equation will be algebraically equivalent. And if we take x equal 1, y has to be -5 times 1. So x equals 1, y equals -5. That is another eigenvector. This one goes with lambda equals -3. And this one goes with lambda equals -5. Do not mix those up. The eigenvalues go with the eigenvectors, because we calculated this vector is the one that's stretched by -5. That's the definition of eigenvector, is matrix times vector equals number times vector. There's only two numbers that work. These are the two numbers. And there's only two lines of vector that work, this one and this one, or any multiple of those, but no other vectors will be eigenvectors. Okay? Now, you could put this in Wolfram Alpha, and it'll do it for you. I think they give you -5, and then they say, what? They say -1, 5. I think I said 1, -5, but of course those are really the same vector. One is just pointing in the opposite direction. So they're in the same line of vectors. And similarly for this one, you could have picked, 1, -3. They picked what? -1, 3. And those are in the same line of vectors. So it doesn't really matter which one of those you pick, or even if you had picked 100, -500, it doesn't matter as long as you're in the correct line. Okay, but the point is that we can construct the homogeneous system, or the homogeneous solution, as C1 e to the -5t times the eigenvector that corresponds to -5, which was 1, -5. Okay, 1, -5. Plus C2 e to the -3t times the eigenvector that corresponds, and I think that was 1, -3, if I remember correctly. Yes, 1, -3. Okay, so that's the homogeneous solution right there. The problem is this is a forced problem, so we need a particular solution as well. Okay, so what's the particular solution going to be? Well, let's go back here. What kind of a forcing term do we have? The forcing term is 30t, showing up in x double prime there, right? So if x double prime is equal to 30t, that means, essentially y prime is equal to 30t. We're going to have something like, well, essentially x prime y prime equals matrix times xy plus 0, 30t. We have to pick something here so when you differentiate it, that's the same as taking this times this, and then you add a t here. So the old trick is just to assume that the thing you're looking for here is the thing that you guess, basically. Okay? All right. So why don't we guess a linear term? Okay. So the forcing term is linear. Why don't we guess linear? And now in this case, right, what's the particular solution? Let's think of this as x prime is equal to y prime is equal to, what was it again? Negative 15x minus 8y plus 30t. Okay, so if you think about this for a second, you've got a t over here, and that's going to equal a y prime, and some combination of x's and y's, and there's x prime is going to equal y. So we could pick, I guess we could pick at plus b for my x, but since x prime equals y, then y would have to be a, right? We can't really just pick any random two functions because they have to satisfy this condition right here, at plus b, and the y has to equal a. So why don't we try that and see if that works. So if we try this as our guess, if we try the guess to be at plus b, and then therefore the derivative of x is y and x prime is a, what will that lead us to get here? So x prime will equal a and y will equal a, so that checks out. Y prime will equal 0. But that has to equal negative 15 times x. X is at plus b. Minus 8y. Y is a. Plus 30t. Okay, so 0 has to equal negative 15 at. Minus 15b. Minus 8a. Plus 30t. And all of this has to equal 0. So how can we get these things to cancel out? Well, here's 30t. And here's negative 15 at. So what if I set a equal 2? Won't that make a 30t negative and a 30t positive and cancel those out? I think it will. So I like the idea of a equals 2. But how does that reduce our problem down? Then we'll have 0 equals negative 15b minus 8a, but we just said that a was equal to 2. So you would have to solve 16 equals negative 15b. So if we set b to be 16 over 15, negative 16 over 15, then 16 will equal negative 15 times b. That will also check out. Okay, so we've got our guess. We essentially have 2t plus negative 16 15ths, and then 2. That is, I should write that as a vector, basically. That is my yp. Okay, so this got a little bit messy. Let me write it down on the next term. So my yp is the vector function 2t minus 16 over 15, and then 2. And my homogeneous solution, I'm just going to copy this because we had it a second ago. Let's paste that down. So my general solution then should just be the sum of the homogeneous and the particular solution here. So I've got C1 e to the negative 5t times 1 negative 5 plus C2 e to the negative 3t times 1 negative 3 plus my particular solution, which is 2t minus 16 over 15 and 2. And that's the general solution. And for the initial value problem, it was supposed to start at position -4, velocity 0. At time equal to 0, I get, what do we get? We get C1 and -5 C1. We get e to the 0 is again 1, so we'll get C2 and -3 C2. And we will get, if we plug in 0, we'll get -16 over 15 and 2. And that really should just be 2 equations and 2 unknowns. And it is. All right, so we got a little bit of algebra to do, but once we crack this algebra, then we should be ready to solve the initial value problem. Okay, so I'm going to copy the algebra down onto the next page, find C1 and C2, and once we've done that, we'll know C1 and C2, and that will be our initial value problem solution. All right, oh, we lost it. We got to recopy this. Okay. Okay. So if I add 16/15 back to the other side, I'll get -4 plus 16 over 15, which should be, what's -4? Is that -60 over 15 plus 16 over 15? So that would be 44. -44 over 15, that has to be C1 plus C2. And -2 has to equal -5 C1 minus 3 C2. So there's my 2 equations and 2 unknowns. I think I'm going to take this one times 3, or maybe times 5 is actually even better, and then add the 2 equations together. Because if I do that, I will get 5C1 minus 5C1, that'll be 0. And I'll get 5C2 minus 3C2, that'll be 2C2. And I will get -44 over 3. If I multiply by 5, the 15 becomes a 3. And then minus 2. And that would be the same as -44 thirds minus, what, 6 thirds? Which would equal -50 over 3. And that equals 2C2. So C2 has to equal -25 thirds. Okay, there's my C2. And my C1, we'll figure out C1. We have -2 equals -5 C1 minus 3 times C2, which is -25 over 3. So -5 C1 has to equal 25. I'm going to have to subtract that to the other side, so I'll have -27. So C1 is going to equal 27 over 5. So there's my C1. Because this is plus 25, so it gets subtracted to the other side and then divides by -5. Okay, so there's C1 and C2, and so I could go back to my my general solution. I could copy it here if I can. Oh, the struggle is real. If I copy it here, I can paste it onto a fresh page and clear out the trash here. And I can call this not the general solution anymore, but the actual solution. And I just have to replace C1 with 27 over 5. So 27 over 5. And I have to replace C2 with -25 over 3. And that should start out at position -4, velocity 0 as the initial condition. And that will, oh, this looked a little bit messy here. 2t minus 16 over 15, I think, is what that was supposed to be. I don't know why it got compressed like that. Clean that up there. Okay, but that is my final answer for the solution to the initial value problem. And of course, if you want x of t, y of t, you can pull those out. X of t is just the top, and y of t is just the bottom in that vector function there, right? So y of t, the vector, is really just the vector xy, right? So you can pull them out separately, or you can leave them as a vector in this case. All right, so hopefully that helps you kind of see how you can put all these different things together into one solution. And we'll see you next time.